All right, here's my second example of a goodness of fit hypothesis test. This time we're going to look at not equally distributed, meaning let's say that we were doing a poll, and let's say that we asked a question and we got the results that 138 were voting yes, and let's just say that 102 are voting no. And historically, maybe this is maybe we are doing some sort of ballot initiative, okay? And maybe historically we've got 55% in favor and 45% against. So maybe this is what the polls are showing, is that 55% are in favor, 45% are against. And so we go and we ask our people in favor or against, and we want to know, is this usual? Like, are we still right around 45 and 55, or are things changing? Okay. So what's going to happen is we're still going to say the distribution is normal and the distribution is not normal. And we're still going to go get the chi-squared, the DF, and the p-value from StatCrunch. But I'm going to show you something different that happens in StatCrunch. So what you're going to do is you're going to put your votes in, and I already put them in one column, so the 138 and the 102. And then next door, I'm putting in, and I just named it percent, but I'm putting in what we expect percentage-wise it should be. It's not 50%, 50%, right? It's 0.55, 0.45. Or if it was 60% and 40%, I'd put in 0.60 and 0.40. Okay. This is important because what you're going to do is you're going to go stat. You're going to go to the goodness of fit. You're going to go to the chi-square. And I'm going to say, yep, I want you to go use my voting data. But here's the important part. If you don't want to equally distribute like we did in the last example, we want it weighted differently, you have to click that button, and then we want to tell it how we want it to weight it. So what we're doing is we're telling it that we expect it to be 55% and 45%, not 50-50. Okay? All right. The other thing that we're going to do is just hit compute. And what you're going to notice this time is that I got a degrees of freedom of 1. My chi-square this time is 0.606, so we'll just call it 0.61. And my p-value is 0.4363. So 0.43.63. Okay. This is obviously bigger than 5%. If it is bigger than 5%, then we keep or fail to reject the null. What that means is I would say, according to my data, the distribution is normal. So the distribution is normal. Okay, what is that saying? What that is saying is that our results are pretty similar to 55% and 45%. There's nothing wacky going on here. It's not like these results are showing 70% and 30%. So we are close enough to 55 and 45 that everything is fine. Distribution is normal. Okay. By the way, because I clicked that expected counts box on StatCrunch, I want you to notice that right here it's showing what the expected should be. So 55% would be 132. And 45% would be 108. And as you can see, those numbers are really similar to each other, those two columns. So that is why the p-value is big. Nothing weird's going on here. Nothing weird's going on here. All right. I hope that example helped.